Last week at this time, many Pennsylvanians were cleaning up after severe thunderstorms the previous day, some still without power. That squall line gave the still relatively new GO-16 satellite a workout and also generated an unusual phenomenon in the ocean beneath. Here's two views of the thunderstorm complex: visible satellite imagery on top, color-enhanced infrared on the bottom. One image per minute starting at 2:30 p.m. last Tuesday and ending at 7:30 when the visible image got too dark. The W's that occasionally appear mark reports of damaging wind, the H's large hail. Sunshine ahead of the line allowed temperatures in the juicy air mass to reach well into the 80s. On the visible image, you can see increasing texture to the clouds as some storms built more than 50,000 feet tall, uncommon in this part of the country. On the infrared, such tall clouds show up as the deep maroon and black colors, with even some embedded white on the southwest edge of the line. Here's the corresponding radar loop. The southern end of the lengthy squall line slowed to a crawl just south of the Mason-Dixon line, with new cells back building or forming westward at the tail end, leading to severe flooding near Frederick, Maryland. This part of the line also produced prolific lightning, including this spectacular triple strike in Center City, Philadelphia. A friend in Downingtown texted me about all the horizontal lightning, adding he'd never seen so much lightning after a line of thunderstorms had passed. Farther north, the threat was damaging straight-line winds and tornadoes. The Weather Service issued 2 tornado watches, the areas in light red here, and 22 warnings, the red parallelograms. 9 tornadoes were confirmed, the black triangles here, 4 in both Connecticut and New York, and 1 in Wayne County, Pennsylvania. There were also more than 200 reports of straight-line wind damage. In St. Mary's and Elk County, the Weather Service estimated winds exceeded 90 miles per hour. And when the line got to New York City, the strong winds blew water right out of a pool on top of a midtown high-rise. Speaking of water, the abrupt changes in air pressure associated with the squall line generated a meteotsunami, an unusual fluctuation in ocean level. The bark is worse than the bite here. Let me show you how this affected water levels, starting with Atlantic City. Now, this graph goes from 5 p.m. last Tuesday until 1 a.m. on Wednesday. Note that during the time when the tide was going out, there's a bit of a spike and then a rapid drop-off in water level. The water level fell about 1 foot in 12 minutes. That is the most noticeable evidence of the meteotsunami at Atlantic City. Now, here's data from farther north. This is the harbor at New Haven, Connecticut. The squall line went through there earlier when water levels were rising. Now, do you see these wiggles that are superimposed on the general upward trend? That's the meteotsunami essentially bouncing back and forth several times in the harbor, superimposed on the overall rising tide. The fluctuation itself was only about a few inches. And that is the case most of the time in meteotsunamis. Changes in water level generally are too small to be noticed, but the weather that produces them almost always grabs attention. Stay tuned. Our extended forecast is next.